Hello, everyone. We are going to talk about electron charges today, and we'll explore one of the most fundamental ideas in physics and engineering, the electron charge of the electron. We'll divide into its discovery, how it's measured, and why it's so important even today. Let's get started. Electrons are tiny fundamental particles carrying a negative electric charge. Their role is absolutely crucial across many fields, from basic electricity to cutting-edge quantum technologies. We'll see how physics, chemistry, and electronic engineering all develop on a understanding electronic behavior. Two key scientists shaped our understanding of electronics. From J.J. Thomson discovered the electron in 1897 through his famous cathode ray experiments. Then Robert Millikan made the first precise measurements of the electron's charge with his ingenious oil drop experiment in 1909. Without their contributions, modern science and technology would look very different. Let's zoom in into Millikan's experiment. He sprayed tiny oil droplets into a chamber and used an electronic field to balance the gravitational pull on them. By carefully adjusting the electric field and measuring how the droplets moved, Millikan was able to calculate the fundamental unit of electric charge, the charge of a single electron. This experiment confirmed that electric charge is quantized, meaning it comes in discrete packets, not continuous amounts. Thank you for listening to me, and I hope you enjoy my presentation.
Hello, my name is Nelson Gomez, and today I am doing the section 5 through 8 on the electrons presentation for my group, the electrons charges. So let's go ahead and get started on slide 5 here. So starting off with the difficulties and benefits of the electron charges. Of course, this wasn't easy. McKillican, I believe that's how you pronounce his name, faced challenges like measuring incredibly tiny forces and keeping conditions perfectly stable. But the benefits were huge. His results proved that charge is quantized, helping shape the atom model that we know today. So moving on to the next slide, slide 6, the modern experiment process. So of course today we use far more advanced techniques to study electrons, like laser traps, quantum dots, and scanning tunnels, microscopes. They let us manipulate and measure single electrons with incredible precision. Computer modeling and quantum technologies help refine our understanding even further of this process. We came a long way from balancing oil drops, and now we have laser traps. So moving on to the next slide, slide 7. So this slide we're going to talk about the modern impact. So first of all, we ask, why does this matter? Modern discoveries about electron behaviors had led to quantum computing, advanced semiconductors, and high precision sensors. Looking ahead, scientists are even exploring the possibility of sub-electron particles and using electron behaviors to help detect dark matter. To summarize dark matter, it's pretty much one of the universe's greatest mysteries. It's up in space, but that's a topic for another day. So moving on to slide 8, we have example questions, the motivation. So here we have the question, how does quantization of charge impact modern electronics? The relevance to this is basis of digital system, binary logic. The motivation is understanding how information is stored and transferred. It's pretty much foundational. Every digital system from your smartphone to huge data services relies on binary logic made possible from quantization of electron charges, which is pretty nice if you think about it. The uniqueness to this connects fundamental physics to everyday technology. So that's pretty nice.
Hi, my presentation is over understanding the electron charges. Question development process. Brainstormed with group, refined to clarify and the relevance. Why it matters, shows real world application of theory. Example question solving. Question: what is the force of an electron in a uniform electricity field of 1000 NC? Conclusion and extra information. Additional info: electrons play roles in bonding current quantum states. Interest: group members interested in electrical engineering, quantum computing. Summary: electrons through tiny have massive impact.